that is both import mode and direct query. We'll see how that works in comparison to composite models during this talk, because they're both slightly different ways of achieving combining import and direct query, but in different ways to achieve different goals. So hopefully that makes sense as far as what we're going to be looking at and the content of this session. Let's look at these in a little bit more detail. So import mode, we start out with sucking the data out of a database, data lake, Excel, whatever it may be. It is the absolute best way of getting started still. It is simple, it is fast. The Vertipack storage engine inside the Power BI dataset is incredibly good at compression, 10 to 1. But more importantly, it detaches your reporting workload from your underlying database system. So let's say you've got a Dynamics CRM database or a Dynamics AX database, whatever it may be. The purpose of that is to operationally run your organization. What you don't want is 1,000 people running reports over it to get information, to get a lot of information, and slowing it down. So you don't want that underlying database, the operational database, having to service all of these analytical reporting as well. So Power BI refreshes once a day, once an hour, whatever it is, sucks the data out, and then all of your reporting workload just hits Power BI and doesn't have any impact whatsoever on your source database. You get the full scope of functionality of Power Query, DAX, and everything else in Power BI. There are no limitations on this. Import mode gives you everything. But there are some downsides. We have to refresh the data set. We have to suck it out of the source into Power BI. And you don't want to do that every 5 minutes. You can't do it every 5 minutes. You're limited to 8 refreshes a day in Power BI Pro or 48 a day in Power BI Premium. So you could do it every quarter of an hour. But that's still quarter of an hour data latency. And really, that's going to hit your source system a lot during the day. Normally, you see once a day, once an hour. So your data may be a day out of date or an hour out of date, and beware of that latency. We've got some data sets that take 3 hours to process. So be aware of how long it takes to suck that data out. And we'll look at ways you can enhance that and improve that later on today. But also you're limited on data size. You don't want to put a terabyte of data up there in Power BI. It's not going to handle it. You can have a couple of gigabytes of data. If you've got premium, you can have more, but you want to keep that relatively small. So what happens if you need zero latency, if you need live reports, or if you have multi-terabyte, petabyte data set that you need to show in Power BI? Well, then direct query comes to the rescue. There's zero latency. You don't suck the data into Power BI. You keep it in the source. And that means every time anyone loads a Power BI report, every time they interact with it, they click on a filter, they click on a visual, they change a page, every interaction generates the DAX queries to populate the visuals. It turns those into a SQL query, which it passes down to the source database, and it runs that live. So you're going to have a lot of SQL queries. So zero latency is live data. There's no processing required because the data doesn't need to get into Power BI. And therefore, the actual memory requirement of Power BI is very low. But it's very slow. Well, I say very slow. It depends on the performance of your source system. Can your source system handle hundreds or thousands of analytical queries? Now, most source systems are designed for operational purposes, viewing or editing one record at a time. If you want to view 3 years worth of sales from your ERP system, well, you've got to query 3 years of sales to give you a chart to show your monthly sales over the last 3 years. That's querying potentially billions of rows of data. How fast can your database handle that? You're also limited on what you can do in Power Query and DAX. So if you're familiar with the concept of query folding, whenever you do data preparation in Power Query, so you connect it to a source table, you do a filter, you do a top 1,000, you do a remove columns, all the different operations you do in Power Query, most of those Power Query will try and convert those into a SQL query and push that down to the database. So instead of bringing back 1 billion records into Power Query and then filtering to the top 1,000, it will just fire off a top 1,000 queries to the database. and that limits the workload. And that's called query folding and makes it hugely more efficient. Some things can be query folded, some can't. Because direct query by its sheer nature has to pass that query down to the database every single time you interact with a report, you are therefore limited to only those Power Query operations that can be query folded and can be pushed down to the database. And so that does limit you to an extent in Power Query. And also in DAX, you lose the ability to do things like time-based calculations, any previous year, previous period, year-on-year kind of calculations. You would have to calculate your own in DAX rather than using the built-in DAX functions for that. The biggest con, though, is really that it hits the source system. It is going to put a massive workload on your underlying system. We've got one customer, a big manufacturing company, who wanted a suite of dashboards displayed around their manufacturing site in their factories, so they could see the productivity in real time of all of their manufacturing stations. And this is running off a Dynamics AX database. And to run, I think 6 or 8 dashboards, I can't remember, that refresh every 5 minutes. Their underlying AX database is running at about 95 to 100% CPU 24/7. So you can't do that on a live system. So they had to get an always-on clone of an on-prem database. And that obviously costs them licensing costs for that, another enterprise license. And so you've got to be very aware of the impact on that. You will often see a limitation of direct query being a 1 million row limit. And this is a bit, it's not really a fair limitation, because it makes you think, oh, I can only query 1 million rows of data. Well, that's not correct. It can only return 1 million rows of data to Power BI. You don't really want 1 million rows of data in one visual. You want 20 rows. You want it aggregated. And it's the aggregated set that is the count, not the raw data. So I could query 1 billion rows. And if I'm aggregating it to product level, and I have 500 products, it's going to return me 500 rows. So the 1 million row limit, I've never known anyone actually hit that. If you are hitting it, I would say your Power BI design is wrong, rather than being a limitation of direct query. But given all these limitations that are valid, the single standard rule is do not use direct query unless you absolutely have to. So then we end up with, well, what if we have 1 billion rows of data, a terabyte of data that we need to report on? If we can't use direct query, what do we do? Well, then we get composite model. A composite model is where we have a bit of a hybrid of some data imported and some data in direct query. And if we can work out a subset of our data that can satisfy the vast majority of our reporting, let's import that data and use that for the majority of our visuals. And where we have the exception, the one visual that actually really does need extra level of detail, well, that can then divert off to direct query. Now, you still have a lot of the limitations because we're still using direct query here. So you still have limitations on DAX and Power Query and things like that. But it gets over the issue of hitting the source database in quite the same way as direct query. So this is usually a much better option to choose. But there are some challenges. Variable performance for a start, and we'll look at this. Depending on whether it hits the direct query data or the imported data, your performance will drastically vary. So let's look at an example of this. Let's say we've got a website and we're tracking the number of page views, number of hits. We've got the number of times a particular website has been viewed, and we've got 3 dimensions in this scenario. We've got our web page dimension, our date, and our time. Now that fact website hit, let's say, for example, that's a terabyte of data. We don't want to import that. But if we look at this model of our 3 dimensions, we can look at the business reporting requirements and see, well, in 90% of cases, 95% of cases, the reporting is going to be based on web page and date. Do we care whether they look at it at 10 o'clock in the morning or 3 o'clock in the afternoon? That really is a secondary, occasional dimension. Our primary dimensions are page and date, so we can see sections of the website over a long period of time and view trending on it. So if we in our database create a view over the top of our fact website hits, we could call that our aggregated view. And so we could have our raw table as direct query, our aggregated table that has no concept of time. It is literally select everything from the fact table, group it by page key and date key, do a count of rows and all the rest of it. That's going to be, under 1%. That's going to be maybe 0.1% of the size of the original table. But it still gives us full reporting capability over pages and dates. We just don't have time there. So before composite models were a thing in Power BI, you could still do this, but you have to do it manually. You have to bring these two tables in and then write some DAX to say, is the query that I'm looking at, is the filter that I'm looking at, is the time dimension filtered using the isFiltered function? If it is, let's go to the slow table. If it isn't, we can ignore time and we know we can go to our aggregated table, page and date. So we used to have to do that manually. Whereas now we have the built-in concept of composite models inside Power BI, so we can wrap those two up as one virtual table. And Power BI just handles everything for us. So let's have a look at that and see what it actually looks like in reality. So hopefully you can see Power BI now. I've got three tables here. I've got my website page, my date, and my time. Now these are all in import mode. And you can see they're all the same because they've all got the white banner at the top, white titles. So I'm now going to bring in my fact website hits. So I'm going to bring in, let's get the right database, that one there. So I've got my fact web hit here. I'm not going to do any transformation on that. And I'm going to, obviously that's a very, very big table, so I'm going to do it in direct query. Now you can see that's colored it differently. That's now got a blue bar on the top, and it shows that because this is a different storage mode, direct query. So it's a very easy way of seeing there's a fundamental difference between the two here. And now we can create our relationships between our tables. Let's join time key. And web page key. Okay, let's go back to our visuals and let's create some measures here. I'm going to create a total duration, which is just the sum of the load duration column. I'm going to create the number of hits, which is a count of the rows. And I'm going to create the average duration of how long does a page view take on average using the average function in Power BI. So I can bring on my, I don't know, the number of hits, and we can now see the spinner is running on the top. Why is that spinning? Well, because it's having to convert that into a SQL query, send it back down to the database, and then return the data. It wasn't too bad, actually. It was okay. Let's now break that down by, I don't know, let's look at the date dimension and bring it down by calendar year. And again, we've got our little spinner going on the top there. Now, this isn't really the Power BI experience your users want. Interacting with a report and having to sit there waiting for 20 seconds to get a result. It gets there. It gives the right results, but it's not ideal. What I'm actually going to do is if I load up as a data studio, I can connect to the same database, press Alt-P and load a profiler session, and that's going to create a profiler. So I'm going to add something else onto here. Let's, I don't know, add a filter by month name as a slicer. And if I filter by May, you can see the spinners going. And if I come back to Profiler, you can see the query that's been run. What it's doing there is it's doing a count big of, and basically selecting everything from this fact web hit table. So you can always use this profiler to see what's going on in terms of the SQL conversion to be able to do this. But if we scroll down here, we can see it doesn't inner join. And then it starts building up its own virtual table, just using a SQL query. These are all the different date keys. Now, the reason it's doing this is because the date dimension in Power BI is in import mode, and we applied a filter by month. Now, the SQL Server doesn't have a concept of month. It doesn't understand how that all relates together. So Power BI is creating this temporary virtual table, mapping every single date key into this virtual month. And this is quite a big, long query. And then it can join it together in the SQL statements, and then it all just works out. But these queries can get massive. Now, the reason it's having to do that is because if we look at our data model, this is in import mode. That was in direct query. So we filtered by month name. So it basically has to create this virtual table, mapping all of these date keys and month names together, passing that down into the direct query to say, okay, now group it by this and give me a sum of this table. We can actually get around that by turning this date table into not just, if we look at the properties advanced, we can see the storage mode down here. Now it's currently in import mode. Well, that also has an option for direct query and for dual mode. This dual mode is the important thing here, because if we set that to dual mode, that one table can act as both direct query and as import, and it'll automatically flick between the two depending on the scenario. So if we change it to dual, it would actually help that and give us a much more efficient query. The challenge here, though, you'll see that's grayed out. You cannot change an import mode table into direct query or dual. You have to delete it, add it as a direct query table, and then change it. So if you do want to create dual mode tables, plan that at the start, because it's quite difficult to change later on. Okay, are there any questions on that so far? Didn't know you could fire up a profiler in Azure Data Studio. Yeah, it's a hidden feature. So you can, there's various ways of doing it. There's actually a plugin. I can't remember the name of the plugin, but the plugin means you can right click on the server and launch profiler, or you can just use the Alt P. So it is an extra plugin to do, but it is quite a handy little tool. Any more questions, please fire them off in the chat window. Right, so we've now got our import mode, and we've seen the performance of this. It's not great. So let's collapse that down, make some more space. Let's now bring in our aggregated data. Well, if we go back to Azure Data Studio, I've got a view here. If I go into my views, called fact web hit page date. Now, all that is it's selecting from our fact table. We're grouping it by date and web page. And then we're just, obviously these are our two grouping keys, and we're doing a sum of our load duration, a count of our web counts, and a count of our row counts. So it's just aggregating that table. We're then going to bring this view into Power BI. Let's get data. And this I'm going to bring in import mode. Now, obviously, because this is grouped, it is drastically smaller than the underlying fact table. So it loads pretty quickly, hopefully. I think this is a SQL database is only a standard S10, so it's a reasonably low performance database. But it does get it. There we go. So that shows a white top because it's in import mode, the same as these. and it's created our relationships between them. So we want to blend these two together into one virtual table. You can see at the moment we've got our two different tables showing here. Well, if we right click on this new table and manage aggregations, this is how we define, how we tell Power BI how these all work. So the first thing we're going to do is say, yeah, this is the aggregation table, and this is our precedence. You can have multiple aggregated tables, all aggregated by different combinations, different grouping columns, and this is where you set the priority of them. So we know, looking back at our query, we are grouping by date and website page. So let's tell it what's going on here. We are grouping. What are we grouping? Well, the fact web hit table, and this is grouping by date key. The website page, we're grouping same underlying table by the website page. So this is telling it basically what the view does. What else are we doing in our view? We are taking a sum of load duration and calling it load duration ag. So load duration ag is a sum of fact web hit load duration. And row count is going to be a count table rows, and web hit count, well, let's just say that is a count of the primary key because it's a one hit per row. So let's do apply on there. Now straight away, that makes this table hidden, because this table doesn't actually mean anything to users. All it's doing is acting as a shortcut for this table. This is the one that users want to see. And Power BI is then going to say, well, can we calculate our measure instead of by using this? Can we calculate it from here instead and save some time? Let's see how that works. So we've got our same visuals here, year and month. You can see from interacting with that how fast that is. That is not using direct query. That is imported. Straight away, we can see that from the performance. And so you can see, even with that large data volume, the aggregations help us out there. Let's add another filter here on time, time hour, and put that as a slicer. So if we search for 5 AM, you can see now we have a spinner going on. Because as soon as we select time, we can no longer use the aggregated table, and it has to revert back to the imported table. And I mentioned earlier about the unpredictable performance, and this is why you get this, because depending on which dimensions and attributes you're filtering on, you either get really fast results or really slow results. And you tend to get a lot of questions from users who don't understand why. And so even though it's a very powerful feature, it can lead to some frustration if your users don't really understand the nuances of why all this is going on. Okay, so I'm going to get rid of the time filter. So we can see here that with our hits, we can get everything nice and fast. Let's copy that and put on a different measure, our total duration. Great, that's also working nice and fast. So we've got our hits and our total duration. Well, what about average duration? That's just total. That's just total duration divided by hits. So that should work as well. So why is the spinner going on? For some reason, it's not hitting our aggregated table, even though the two source components of it are. Well, if we look at our average duration, we're not actually doing a calculation of one divided by the other. We are using the built-in average function. So what does that do? Well, it takes the sum of that column divided by the count of number of items in that column. Well, if we go to our data, our aggregations, we can see that we have the load duration sum. So we've got the sum of that column, but we don't have the count anywhere. When we did our count, we counted the primary key of the table, not the load duration column. Now that's very important because when Power BI counts a column, it excludes nulls. So a count of one column is not the same as a count of another column, and it is very important to get the right column so Power BI can actually calculate it properly. If we change this to say the webhit count is actually a count of that load duration column instead, and apply it, and then go back to our visuals, we can see that's now working. So be very careful when you're defining these aggregations, because it is very important to get the specific details of each column correctly. There is a way of actually looking in similar to Profiler. You can actually run Profiler against the underlying Power BI data sets and see in the Profiler whether it's working or not, hitting aggregations, but we haven't got time to go into that today. If you want some information about that, then let me know. Okay, right. So we've now got quite a nice little hybrid report. We get most users doing nice fast reporting. And for those that want to do more detailed hour-based reporting, they can, as long as we educate them to know that they're going to get slightly worse performance. So let's now say, well, we've created this complex data model. Obviously, in this case, there's only a few tables. In reality, there may be lots of tables. You spent a lot of time building this composite model, and you don't want all of your users to have to learn how to do this. So you want to be able to publish this and then reuse this same dataset logic for other reports. So we can do that by publishing our report. And I'm going to put that in our demos workspace. And if we then open that up, we're going to get the same report and we get exactly the same performance. Imported mode, and then choose a time, and suddenly it goes slow, direct query. Great, happy days. So now we want to encourage other users to build their own visuals, their own reports over the top of this data set. If we open up a new Power BI report, we can get data, and from get data, we can get our Power BI datasets. And that's going to look at my powerbi.com profile or account, see what datasets I have available. And here we go. Here's our PBUG Stuttgart dataset. I'm going to connect to it. So it brings in the same data model. We can see it never lays it out properly. Very frustrating. Let's go dates. Web page was over there. Date was there. Let's relay everything out properly. And time was down here. Okay, so it's still inherited the same data model. But if you remember when we looked at the last one that we built, all of these colored bars were different between import and direct query. Now they're all the same, because if we hover over this, we can see they're all a SQL Server Analysis Services database. So I mentioned earlier, Analysis Services cubes and Power BI datasets are two of the same. They are pretty much the same thing now. The only difference is this is an Analysis Services cube hosted on a Power BI server, and it gives you the Power BI URL there. That's the name of the workspace that we're in demos. And the cube is called PBUG Stuttgart. Now, all of these tables come from the same source, Analysis Services. So therefore, they're all blue. They're all the same source. We can see that it's still got the aggregate table hidden. So let's build a report off this. Let's build our average duration broken down by month name. And let's do a calendar year as a slicer this time. And we get the same, hang on. I think I've got a relationship issue there. Let's change that around. I must have got a relationship the wrong way around. Let's add year onto that. Actually, yeah. Bear with me. There we go. So we can see we've got nice fast performance there. And let's add on our time as another slicer. And we get back to where we were. Back to direct query again. So, with a nice slow spinner. So in this case, we've got a user who's building their own report, dragging their own measures in. They don't understand how that underlying composite model was created. So they have nothing in their power to understand why some things are fast and some things are slow. So just do bear that in mind. Training is absolutely critical. Now we're in this, we can't do anything with this data model. What we can do is add more measures. So we can add a new measure. And so measure equals 1, doesn't matter. So you can add a measure here, but that's all you can do. You can't do anything else. Let's say I'm in the marketing department and someone's given me this data set of website page views. The first thing I want to do is overlay that with information about my sales. Oh, hang on, I've got a question here. Could you show the hits measure, please? Does it change, or does Power BI automatically change the fact table? Right, okay, good question, Fernando. Let's go back to our other reports. So the question was, after we made this a hybrid, what does this hits measure actually do? Nothing. It stays exactly the same. You don't have to change any of the DAX. What happens is that we're telling Power BI that the hits measure is counting the rows of the fact web hit table. Now, we know we're trying to view hits. We also know that we are filtering on the date dimension, but that's it. There's no other filters. So Power BI would say, right, we want a hits measure, which comes from here, and we are filtering by the date dimension. It will then look to see, okay, can we use this aggregated table? Yes, we can, because that has a relationship from the filtered table. Therefore, Power BI will say, right, I want to calculate hits. How do I do that? Let's go into manage aggregations. The count of hits is simply the count table rows, which we've got here. So it will it will replace internally the hits measure with that measure there. And that's all automatic. It happens without you having to do anything. It's all controlled by this definition of how these two tables interact. And Power BI will say, right, I want to calculate the count of this table here. I know I can take a shortcut and do it from this table here, which is imported and is going to be much faster. One thing I didn't mention actually is we created these aggregations automatically. Sorry, we created them manually. There is now a preview feature called auto aggregations, where Power BI will start monitoring how direct query tables are being used. And it will automatically build aggregated tables for you based on your usage. So the more people use specific data and combinations of dimensions and measures, it will automatically create the aggregations for you without having to do anything. Now, for anyone that's ever played with automatic index tuning in Azure SQL DB, you know that it sounds like a really great idea. In reality, it is horrifically bad and causes more problems than it solves. In all honesty, I have not tried the auto aggregation feature here. I like to be in control. I like to have predictable performance, so I know exactly how it's going to work. But I think for end users who don't necessarily understand the nuances of composite models, it could be a useful feature. I just think it's quite dangerous because you're encouraging users to build a direct query report and letting Power BI just manage the performance. I think that's quite dangerous personally. So I'm yet to be convinced that auto aggregations is a good thing, but time will tell. Okay, Isa, we can't create aggregations with cubes in analysis services. Correct. Aggregations is purely a Power BI feature, not analysis services. I do not expect that it will come into analysis services. I think it will stay as a Power BI feature. You're starting to see now where cubes were always the big brother of Power BI, had better scalability, better functionality, etc. We're now seeing Power BI datasets have more functionality than cubes. Do they have the same scalability? I would question that. If you have a premium for capability, then they can scale quite big. We have some cubes that would not fit in Power BI. So, but that's changing. Power BI is getting more powerful, and certainly most of the new, really fun functionality is going into Power BI datasets, not cubes. So whereas a year ago, we would, or maybe 18 months ago, 2 years ago, our default position as a analytics consultancy is you should look to having a cube. Now our default position is let's see if we can do it with Power BI Premium and then switch over to use cubes if we need to for scalability or other reasons. Power BI datasets have reached that level of maturity in my mind for the majority of cases. There are still some very good use cases for analysis services, but Power BI really, I think, has taken over now, and it will keep going in that direction. Fernando, automatic aggregations are premium only. That's a very good question. I think you're right. Because I've never really tried using them in anger, I couldn't tell you because I've never tried deploying them into non-premium, but I think you're right. Okay, let's get back to, yes, the second model of where we were connecting through to our underlying data set. So here we have our dataset connecting to analysis services. The question was, is this PBIX model in import mode? No, it's not. No, it's not. So if we, this is in live connection mode. Think of it as very similar to direct query, but different. So what we're doing here is as we're interacting with this dataset, with this report, it's instead of building the DAX query and running it locally, it's sending the DAX query down to the underlying dataset or cube. And it is processing the DAX query and returning us the results. So this report here is empty of data. There is no data in this whatsoever. It is a comparable to direct query where it's purely visuals. There is, however, a big difference. Direct query is over, it has to convert the visuals, which use DAX as native language, into a SQL query, which by default is limiting its capability to direct query limitations. Here, you've got a report over a data set, which natively, they both talk DAX. So there's no limitations. You get the full richness of the whole DAX platform without any limitations. It's really, when you have a Power BI report, it's both the data set and the visuals within one PBIX file. When you deploy it to the cloud, it splits them up into two, a data set and a report. All we're doing here is adding another report, and another report, and another report, and they're all connecting to the same data sets. They all natively talk DAX. You're just basically reusing that data set to service multiple reports rather than duplicating your data sets. And that makes it much more easy to maintain because you've got one data set. We're actually now adopting the mentality of cubes. You have one central cube in your organization and hundreds of reports. Now we're doing the same thing with a data set, but using the data set as that cube consolidation layer. And you can have a lot of reports over the front of it. So, but specifically, it is called live connection because you are live connecting with a data set. Now, what I will show you is, No, I won't show you actually, I'll just talk it through. When you do connect to a data set or a cube, you can choose to import the data from it by writing a DAX query. Don't do that. Just don't do that. What's the point of having this great, complex, rich data model inside your data set that once you start extracting data from it and storing it elsewhere in another data set, you're breaking the flow, the chain, the calculation logic. So there are very, very few use cases that I think are valid for importing data from a data set into another data set. They do exist, but they're quite few and far between and rare. So go back to this model. We created a new measure here. That's all you can do. If I'm in the marketing department and I can see our website hits, let's change this back to total hits because that's more relevant here. Hits, there we go. So I can see how this is changing over the years in May. What if I want to supplement this and say, well, okay, I can see the website hits, but I also want to see sales. How do I overlay my sales data on top of this, given that this is an underlying data set in live connection and I can't change it? Well, if we try and go to get more data and try and bring more data into this report, it gives me an error and says a direct query connection is required. And it gives me this option to add a local model. Now you can also see that down the bottom here, make changes to this model. There's also a button, where is it, on the modeling tab called make changes to this model. They all do the same thing. What they do is they turn this live connection, where you're literally just creating visuals over a separate data set, it turns it into a new form of direct query, but not direct query over your underlying SQL databases. This is direct query over a data set, which is very different. So I'm going to add a local model. What this does is it doesn't clone the data, but it does clone the model. So it imports the structure of the cube, but each table is linked to the underlying table in the underlying data set. So if we go back to our data model view, we can now see this is different. We're now saying it is a direct query storage mode, but it is still connected to the analysis services database. So this is very different to direct query over a SQL database. What happens with the functionality? Well, it all still works perfectly. Nothing changes. What happens if we choose time? Exactly the same. Nothing changes from a functionality perspective in the report, but there's a subtle difference in the back-end structure of how this report is now working. And that allows us to do some fun stuff with it, such as, let's bring in some more data. That one there. So now we're in direct query mode, which again, we can see from storage mode direct query down there. I can bring in my fact internet sales from a SQL Server database. I want to import this data. And this is giving me a security risk. Now, remember when I showed you the profile earlier, where it was building up a virtual table of dates and from Power BI and sending that down to the underlying database? That is sending information from one table in Power BI within the text of a SQL query to my database. If someone else is doing a profiler trace on my database, they could see all the information in my virtual table. If that included email addresses, for example, there's a PII concern there. This is doing a similar thing. So just be aware of when you do have different islands of data. So here's my fact internet sales. This is in import mode, and it's got a white banner on the top. When I link things together, Power BI can take data from one of these islands and build it into the query that is passing down to another island. And that's the security concern of if you don't control both of these islands, you could potentially leak sensitive information. So we've now got our new table of fact internet sales. I'm going to say, right, we need to link this through to our dimensions. Well, it's clearly linked to our date dimension. So let's link it to our order date. But our fact internet sales, we have no concept of time and we have no concept of web page. So really, it's just the date dimension that is shared between these two. So let's now go back to our visuals. I'm going to go to our fact internet sales and add a measure. Let's call this sales is the sum of fact internet sales amount. So on this same visual, I can bring on my sales measure. I want, let's turn that into one of those, put sales on the line, and I can now see both sets of data on the same chart, inheriting the same filters. So what's happening there? Well, we're filtering by dim date. That is, first of all, sending a query, a DAX query, down to our underlying data set, which pulls from one of these. We know from the performance that you put it from the aggregator table. It's also sending a query to this imported table and grabbing this data, but they're sharing this same common dim date dimension, which is used by both of these different islands of data because there's a join there. So we can use this to take existing data sets and enhance them to a level of capability beyond what they're originally designed to do. Now, obviously, if I filter by hour, even though our fact internet sales has no concept of hour, it's still got to hit the direct query of our underlying data set because that is needed for our website hits. And there we go. But you can see how this gives you an ability to really enhance existing data sets and reuse them. Any questions on that? Nothing in the chat, so I'll assume everything's okay. Please do fire them into the chat if you have any questions for that. Right, so let's take a little step back and look at our live connection mode. This was where we created a new report over our data set, and you saw how fast. You saw how fast the report creation was. There's no data modeling. There's no import necessary. It's all nice and fast. Critically, we go back to our age-old favorite single version of the truth. One data set can produce lots of reports. Everything's consistent. Everything's the same. Makes life really, really easy. You only have one data set to process. So all of your other reports just use whatever's there. So simple management, simple to look after. High scalability, especially if you've got a cube, you can scale it up, you can have read-only clones, etc. One of the challenges, though, is you start having to manage it like a cube. So you can't just make a change to it. If you've got one data set linked to a report and you want to make a change, well, you're changing the same report, it's fine. But if you've got 20 other people using that same data set, suddenly you can't just change it. You have to worry about the impacts. You have to worry about the lineage. Who else and what else is using that data set? And what's the impact of your change? So you need a tool like Power BI Sentinel to map out the data lineage for you and the usage logs to see who's using it, what's going on, what can you change, and what's the impact of making that change. But also you've got this rigid functionality of you can't change anything. But that's where the DQ model comes in, where you can start to bring multiple islands of data together. Now, I showed you bringing two islands together, a data set and an import mode. You could link two data sets together. You could link a cube and a Power BI data set and an Excel file. Doesn't matter. Just be aware of how they're linking together. And linking together is the critical aspect here, because the performance of this is going to be directly proportional to the granularity and cardinality of these join columns. If you're joining on date, maybe you've got 10 years worth of data, that's 3,500 days, that's fine. If you've got 5 million customers, do not join on customer key, because every query is going to build a subquery of 5 million customer keys and send it to the other island. So be very, very careful how you join these islands together. Try and make sure that they're joined on a very small, the smallest column possible in terms of the number of data values. Another option is to bring in two data sets that aren't even linked at all. Why would you do this? Well, if we raised a poll of who likes Power BI dashboards, I'm guessing I wouldn't get a single hand because they're rubbish. A Power BI dashboard is simply a pinned visual or lots of pinned visuals from different reports that you can't interact with. And as soon as you click on one of them, it takes you to that report to interact with. Well, I want a report that has bits of information from lots of different data sets that I want to be able to interact with all at the same time. They don't cross-filter each other, but I may have the one part of the report is about sales, one part's about stock, one part is about forecasting, whatever. They're all independent, but each of them operate independently and can be filtered together. Well, you can use direct query over of PBI datasets to do that. You can build these independent datasets, bring them all into this composite model, direct query composite model, and build your visuals and have visuals from every data set you want, all in one place. So it's quite a nice way of building much more comprehensive dashboards. So let's look at the pros and cons of this. You get all the benefits of live connection, plus the flexibility to enhance. And we'll look at a minute how this really helps our data set management within Power BI. But we do need to look at the cons. It is a preview feature. It's been in preview for quite some time. At first, we did find quite a few bugs with it, especially when scaling up. But actually now it's pretty robust, pretty reliable. But there are problems. And they are problems that Microsoft are working hard to resolve, but they don't yet have a fix. One of the main ones is once you create this new composite model over a data set, if you change the underlying data set, it breaks your composite model on top of it as well. And that is the single biggest problem with this DQ over data set composite model that exists at the moment. So you have to be very, very confident that your underlying data set is stable and doesn't need to be changed before using this. Therefore, I would use it with caution. Be aware that it's coming. Be aware that it will be enhanced and will get better. But I would be cautious about doing too much with it at the moment. A couple of questions have come in. So using composite models for fact tables is not a best practice. So which composite model are you referring to? The hybrid direct query and import mode, the first one we looked at, those are specifically designed for fact tables, very large fact tables. Whereas this new composite models, you're absolutely right, do not join on your fact table because fact tables are very, very big. And as I mentioned, the performance is dictated by the number of values in each column. And if you've got 1 billion rows in your fact table, you don't want 1 billion rows in your join condition. So yeah, you absolutely want to join these via small dimensions, not directly from facts. Absolutely spot on. Good question. Okay, what else have we got? Yeah, that's it for the moment. Right. So other things we need to know. So it is in public preview. Surprisingly, for quite a nice new bit of functionality, it does not need premium. It works on Power BI Pro, which I think is great. We've talked about avoiding high cardinality cross-island joins. That's where you want to join on small dimensions, not on big facts. Not even on big dimensions. Small dimensions is key. A few thousand values is fine. You can chain up to 3 of these together. So you can have your first data set, then another one on top of it as a DQ composite model, and then a third on top of that. That's a limitation at the moment. Will it change? Possibly, but I hope not. I think if you start getting more than 3 chains, the management of it is going to become quite difficult. So I think we're likely to stick with 3 for the moment. Be very, very careful with row-level security. Row-level security is supported, but not very well. So if you've got 2 islands of data, one of them has row-level security applied, that will be honored. And it may look like that is applying to the second island, but it is only acting as a filter, not as a row-level security. Now, the difference between the two is row-level security, you cannot bypass with DAX. A filter, you can. So if we go back to here, let's say we have row-level security applied to this table here. Then that row-level security will absolutely be honored in its island. We can see there's a join here, so that also turns into a filter here. And so it will look like row-level security is also applying to this data set. However, because it's only acting as a filter, you can override it with all. And as soon as you do that, everyone can see everything in there. There's no actual enforced row-level security. So yes, it may look like it works, but in reality it won't. So be very, very careful about row-level security. Yeah, there's a new build permission. This is quite an important one. So if we go back to our Power BI and let's go to here, and I'm going to I'm going to add a user. This value there, allow recipients to build content with the data in this data set. That is the thing that allows them to create this DQ composite connection to the data sets and add functionality over the top. So do watch out for that build permission. They can also do it if they are an administrator of the workspace, and I can't remember if there's anything else. Could be a contributor. Didn't they change the build permission? Oh, I don't know that. That's news hot off the press. Okay, so Augustine's saying potentially you don't need the build permission anymore. I don't know that. Potentially, have a look and see. Good knowledge though, thank you. And what else have we got? It does now work on Azure Analysis Services. So you can take an Azure Analysis Services cube and do a DQ composite model on top of it. But it is not supported by on-prem SQL Server. However, I think I may have heard a rumor that the next version of SQL Server on-prem may support it. I don't know if that's me hoping or whether it's actually going to happen. I don't know, but certainly not at the moment. Right, so what are we doing on time? I need to crack on a bit. So let's look at another side of it. Let's go back to our imported data, our website hits. Let's say we've got our big table there. The last time we fixed it, we added a composite model imported mode and left this as direct query. But what if we actually want this on in import mode? Well, if this fact table is taking 2, 3, 4 hours to refresh, what else can we do with this? Well, we can partition it. We can partition it into lots of smaller partitions. So we can have a daily partition, a weekly partition, a monthly partition, and then we only need to process or refresh the latest partition. That's been around for some time. What we now have is what's called a hybrid table, where we can specify that the most recent partition, like today's data, is now direct query. And that means the Power BI will automatically divide our table up for us into lots of different partitions. And the most recent one down the bottom is going to be direct query. So every query we put onto this table, it's going to get most of it from its imported data. And it will then just fire off a query down to the underlying database for today's data, get the live information from that, and then combine the results together into one result back to the user. We don't have time to go into a full demo to show how that works, but basically you just need to create a couple of parameters in your Power Query, very specific names. You've got to call them range start and range end. Add those into your Power Query as filters, and then you can, in Power BI, let's go back to this one. You've got an incremental refresh button here on a table, and it's not letting me do this because I haven't got the parameters set. But if I did, it would allow me to choose how much data I want to store in history, how much I want to refresh, and there's now an extra tick box down here somewhere that says the most recent partition is direct query. And once you've set that, it'll just manage everything for you. When you then trigger a refresh, if we go back to this, the refresh will only update the partitions that it needs to actually get the more recent data. And Power BI then manages the bubbling up of those and converting them into monthly partitions, into quarterly partitions, into yearly partitions. Gone are the days of having to worry about partition management in cubes, which was always a real nightmare. Now you can just let Power BI handle it for you. Right, so what have we got next? So the whole picture we've got. Once incremental refresh is set up, can we still modify the model? Absolutely, good question, Ocean. Yes, there's no fundamental change to the model. In fact, I may have one that I can show you. Bear with me a second. Let's open up. Not sure if I have one or not. No, I don't, sorry. Yeah, even after you set up incremental refresh, all that happens is, is your, by default in Power Query, in fact, let's go through it. Let's just set it up. Why not? Let's, I'm okay with time, I presume I am. Let's go to transform data. Go into Power Query. There we go. So I'm going to add a couple of parameters. So a new parameter, I'm going to call this range start. And that's got to be a date time. And put this 1st of the 1st, 2022. No, I'll put it as this month actually. 1st of the 6th. Create another parameter called range end as a date time, and put that as the 1st of the 7th, 2022. So now I've got that. I need to specify how these parameters filter this table. Now I've got an order date key, but that's an integer. I can't filter that by a date time. Luckily, I've got a date column here, order date, so I can filter this and say I want to say that this table is going to be filtered. It's after or equal to the range start parameter and is before the range end parameter. So that is now going to apply these filters or these dates to this table, and you can see it's empty. I've got no data there. But let's apply that. Suddenly I've got no data in there. If I go on to incremental refresh, I can now turn it on. I want to keep 20 years of data, incrementally refresh starting, I don't know, let's go 3 days. And there we go, get the latest data in real time with direct query, obviously premium feature only. So tick that, and that gives me a little picture of I'm going to have 20 years of archive data imported. It's going to do an incremental refresh of the last 3 days, and the actual current date is real-time direct query. Now, nothing's changed with the structure of this table. I can still interact with it. I can still add measures. I can still change the Power Query. But if I go back to the Power Query, these parameters are filtering the data that's imported here. So even if this table is a terabyte of data in the underlying source, we're only actually importing this 1 month's worth into Power BI Desktop. When we publish this and deploy it to powerbi.com, powerbi.com knows that it's incremental, and it will say it'll recognize these parameters and then do its own job of saying, right, I'm now going to create that partition, this partition, that. It creates all of these different partitions, and in each one, it replaces those date parameters with dates relevant to, that'll be the 1st of Jan 2011 to the 1st of Jan 2012 and vice versa. So it's going to overwrite the parameter values for every single partition and create them all for you. So you'll end up with a huge amount of data in powerbi.com, but your actual Power BI desktop only has to have 1 month of data in, because that's the current partition we're working in. So in answer to your question, can you still modify the model? Absolutely you can. And actually it really helps by using this partitioning on very large data sets, because in Power BI Desktop, you can work on a much smaller subset of the data, which makes it faster to develop, faster to deploy, etc. Question from Augustine. Do you know our hybrid tables are becoming a part of the new Power BI data marts? Oh, that's a good question. I don't know, they won't. Largely because data marts are a fundamentally different thing. They are a SQL Server database. They're not a data set. Hybrid tables are all about the Power BI analytics of your data. Data mart isn't about that. A data mart is essentially, I'm going to say, a poor man's data warehouse. They're a low-code version of a data warehouse built using Power Query. You don't have the concept of direct query in those. It is just what it is. So I don't think it makes sense at the moment to have that hybrid. However, data marts are not in their final form. They will keep evolving, enhancing, and getting far more powerful over time. Where they get to, who knows? We'll wait and see. So I think ask the same question in 6 months to a year's time. There may be a different answer, but at the moment, two different things. Another question from Hersham. Am I right to say this would work on data set only, as a data flow will create a range and range start and then automatically? I've never actually tried to create an incremental refresh data flow. Can you even do it? I don't know. I presume you can. Honestly, I've never tried it. In this mode, obviously, we're in Power BI Desktop, and yeah, this is relating to the to this particular data set only. I know that with data flows are just Power Query, but yeah, I've not tried actually creating incremental refresh in them. Yeah, good question. Don't know. I'll try it and see. To be honest, I don't really use data flows. I find them very, how can I put this politely, frustrating and not conducive to a good, well-managed data environment. I think you do need to have a better structured data layer. Data flows are a way of easily getting access to information within Power BI environments, but does it help or hinder? I personally think they hinder more than they help. That's just my personal view. Don't tell Microsoft I said that. Right, let's crack on. So let's have a look at the whole picture of what we created today. Well, the original data set was a composite model of both DQ tables and imported tables side by side, acting as one table together, where Power BI automatically switches between them to give you the best performance possible over that table. Obviously with our dimensions being in import mode or dual mode. Then layered a new data set over the top of that in direct query composite mode, where we then had that link to the original data sets, but also imported our own data as well, to give us a much more powerful approach. Now, what does all this do from a governance and management perspective? Well, we're always trying to strike a balance between agility and governance. The speed of delivering new functionality versus how well centralized that is. On the top left, we have old school data warehouses and cubes, highly centralized, highly standardized, highly governed, good development practices, but typically slow to roll out. On the bottom right, we have Power BI, very fast to create, very quick to deploy new reports, new data sets, but completely ungoverned. Anyone can do whatever they want. These new hybrid models, composite models, etc., really give us an ability to pick a point on that line where we can actually choose a better method of standardizing reports. So here I've shown this as a cube up here, but that could be a cube or a data set. Typically, you would build that centrally, and you may get a few users creating reports over the top of it. So this is our central BI team up here. Then we have our departmental teams, and we have individuals over on the right. Well, with these new direct query modes and hybrid modes, we can now say we'll take this central data, layer on some new information, and build our own customized data set for this particular department or team. That means, yes, they're doing their own thing, they're building their own flexibility, but that's 10% of the data. The 90% coming from your centralized, standardized source. So you're maintaining this centralization and standardization whilst also enabling more rapid development as well. And that really is the real benefit to me of these new DQ models when they get finished and put into full GA production, is it will facilitate this. And I mentioned we have these 3 layers of this. So we've enhanced it here. We can then enhance it again. So someone, a power user, can take this team-based data set, add their own Excel file of forecasts or other information that they've got, so they can again reuse this 95% of standardized centralized data, but enhance it themselves. Then what if this data set actually becomes quite useful? We're going to want to centralize it and standardize it. Well, this is where data flows can come in. You can take that data, put it in a data flow, and then expose it to multiple people in different departments without having to build it into the data warehouse or data lake. I would still say, as a data person, I would still want it to come into the data warehouse if it is relevant to the business. But it gives you more flexibility and choice as to what you do with it. So just to very quickly wrap up, import mode, yes, use it, still number 1, absolutely. For most of your report, this is still the number 1. Direct query, big bad no, red flag, avoid like the plague. Composite models, really good way of scaling up very large data sets while still retaining that flexibility to bring big data into Power BI. Live connections are the best way of standardizing multiple reports over your centralized, governed Power BI data sets and cubes. And then you've got our new DQ, AASA, PBI, DS, which adds that centralization with the newfound customization and enhancements, but used with caution because it's in preview. And then our hybrid tables come up here where we're saying, right, an individual table can now be both incremental and direct query, sorry, import and direct query, to give you live real-time data. So you put all this together and you end up with actually quite a lot of options available to you on how you want to bring your data into Power BI. There is no single right choice. Hopefully you've learned from this session where the different scenarios are that they can combine together to work. That is all I wanted to go through. So a very big thank you for all of your time. Hope that's been of interest. I will hover around for any more questions if you have any. There's nothing else in the chat window. A couple of very useful links. Thank you to everyone who's pasted links in there to answer some of the questions. Very useful indeed. So thank you for that. And yeah, a very big thank you to Augustin and Christian for hosting tonight. Really appreciate it.
Thank you, Alex, for joining us. It was really insightful session and a lot of things to comprehend if you are not completely into it. If there are any questions, so feel free to unmute yourself or type in the chat. So while Alex is still here, and from user group side, so we are here next week again.
Of course, if you want better governance and management of Power BI, then go and check out powerbisentinel.com. Table level lineage, full auditing, permissions management, everything you want to know about Power BI, all as a software as a service solution. No more questions coming through, so I think that's probably got everyone happy.
Probably, I think they are with end-to-end session. So thank you very much, Alex, and it was really helpful. And hope to see you again in our user group. So such session.
My pleasure.
Thank you, everyone. Thank you for joining, and see you next week when Ben Howard is with us with another great topic.